Hey everyone. Welcome to this SDE Skills Leetcode session. So we have Gaurav who will actually be walking us through the questions for the day. Gaurav, just take it over from here. Thank you.
Hello everyone. Hopefully everyone can hear me fine.
Yeah, we can hear you.
Yeah, okay. So we will start with the first question, which is binary search. And anyone want to explain what a binary search is? I'm taking one example, a sorted array, and let's say we have to figure out the number 3, the index of number 3 from this array. So how can we apply binary search to it? How we can find the index for number 3? Anyone want to take it? Please unmute yourself if someone is speaking.
Harshan says search like a dictionary. Can you elaborate and can you maybe get on the audio bridge and then talk through that?
Hi.
Hey.
This is Hugh Chen. Yeah, you basically search the way how a human search a word in a dictionary. You randomly go to somewhere in the list. Well, in this case, you usually go into the middle of the list and you compare the middle item whether or not it is the target. If it is not, then you compare, make sure it is figure is larger or smaller than your target. If it is smaller, you basically search the left side of your list from your middle point. Otherwise, you could search for the right side of the list from your middle point, and then you repeat the process until you find your target number.
Yep, that is correct. So basically, we have a start point as 0. We have end point as the string, the array length. Let's say if our array is array -1, the end index, and then we have to find the mid first. So how can we find the mid? What should be the equation?
You basically add the start and end together and divide by 2, assuming that there's no overflow.
Yes. Then the first condition.
Well, if the middle the element in the midpoint is your search target, then you just return the index that you just got, the mid.
Let's say this is the array and the target is 3, so we will return mid here. Fine.
Yep.
Otherwise,
well, it's not mid. You compare the element in the index of mid, not the.
Yeah, sorry. I just go to mid here.
Array. Yeah, array.
Yeah, because we are looking for the index. So if the middle element is same as the target here, then we will return the middle element.
Yep. If it is smaller than the target, you repeat the process again. Instead you reinitialize your n variable to mid -1.
made -1, okay.
Yeah. Else you do
Hey, Gaurav,
start equal.
the screen sharing is off for some reason. Is it? No, it's fine. I can see it. Go ahead.
Okay.
Else you do start equal to meet +1.
Okay.
And the whole thing from line 34 should be within a while loop. From line 34 to the end should be within a while loop where you make sure the condition is always true when start it is smaller than or equal to n.
Okay.
And if you exit the while loop, that means the target is not in your array, then you should, I don't know, you should return -1 maybe.
Yep, that's fine. So if we don't find the element, we can simply return -1 or like throw an exception saying index not found, like element not found. Yep, that is fine. Anyone like, do you see any issue with this solution? It's pretty simple. Like binary search, we do a lot. There are a lot of problems that we can solve like using the binary search. So, Vivek, like, do you see any issue with the solution?
No, seems okay.
Okay, then let's like tweak the problem that we have in hand. Let's say the same problem, but the array that we have is now rotated. Okay, so instead of like the array that we have in hand, let's say if I have to like rotate the array, something like this. So the starting element, like we take the starting element and keep, like we take the 1 first, put it at the end, then we take the 2 from the beginning and then put it at the end. So we have like rotated the array. Can we still apply binary search to it? Yes, or maybe not. Like if yes, like how, and if not, like then what should be the possible solution? Anyone want to take that? It's very similar to the first problem where like we have a sorted array, but in this case, the only tweak is array that is given to us is rotated. Okay. One solution can be maybe like we can sort the array and then again apply the binary search. Is there a better solution?
Well, if you do sort it first and then you apply binary search, you better just do linear search then.
Yep. So let me ask, like for the binary search for the sorted array, what is the time complexity for this solution? The first one that you just like mentioned.
It's log n.
Okay, that is fine. Do you want to like explain like why it is log n?
You reduce this every time you update your start or your end, you redo your search space by half.
Yes, that is correct. So like we have n elements in the array, and every time like we are trying to find the middle element, and then we are discarding half of the element in each while loop until like we find the element, or we return -1 if we don't find the element. So we discard half of the element like in each iteration. So that's why it is the complexity is log n. How about the second problem where the array is rotated?
So I'm thinking in this, maybe we could do, I'm not sure, but yeah, the starting and the ending we'll compare, and based on that we can apply the binary search.
Okay, let me like write it down. So what we are going to compare here, like starting
element and the ending element, so we know it's rotated, and
okay. So here we compared 8 and 7.
Yeah, 8 and 7. So, and the target element. So we are comparing if the target is less than the end or the greater than the beginning. So based on that, we can apply the search, binary search.
Okay, so in this case, target is 3, which is
less than both 8 and 7.
Less than the end and like less than the beginning.
Yeah, but which is we are comparing the beginning and the end also. So 7 is lower than.
Actually, we can probably get the midpoint and then compare the the first element and the last element to that midpoint to know where is the rotation, like which part of the array is rotated. So for example, in this case, if the mid is 2, right, and if we compare the last element, we know that right side is not rotated, right? Then we know we need to go on the right side because the element that we are trying to search is 3. So we can simply compute the mid between 2 and 7 and do the same as the previous one, right? Okay. And if let's say we are trying to search maybe say 9 or 10, then we compare 2 with first element as well, and first element is 8. So we know that it is the left side which is rotated. And if we are trying to compare 9 or 10, trying to search that, then we know that we need to go on that side and not on the right side. Something on this.
Yeah, that sounds good to me. So let's take like these two cases. Okay, where this is the first given array, and we have like the second array, and in both of the arrays, like we have to find the 3. So in the first array, the midpoint is 2. In the second array, midpoint is 9, I guess, like 4, 5, 6, 7, 8, 9. Correct? So can you like repeat like the algorithm that you just mentioned? Yeah. What will happen like in the second case?
So we are trying to search for 3 only, right?
Yep.
Yeah, so in this case mid is 9, so we'll compare it to both first and last element. So we see that left element is 4 and the mid element value is 9, so we know that left side is not rotated. However, when we compare it to the last element, which is 3, so we know that this is the side which is rotated.
Yes.
Okay, then we need to go on the right side basically. So we compute the midpoint of right side which would come out to be 1, I believe. Yeah. So we do the same thing. So we take 1 and then we compare it to 10 and 3, and then we know which part of the array is rotated, and we go to the right side again and we'll find 3.
Let me like write it like for clarity. So here in the first iteration we picked 9,
yeah,
and then we compared
9 with 4 and 3, which is the first and last element of the array.
Yep. So
since we are trying to find 3, okay, we actually know it's on the right side, because that element, that last element, is actually equal to that, so we can simply even return. But let's say if we are trying to search for 2, for example.
Let's say this is the case.
Yeah, that would be better. Yeah.
Yeah.
So if it is 4, then we know it is on the right side, because array is rotated on the right side. So we take element from 11 to 4. We can skip 10 actually. So we can get like mid plus 1. So we'll have these elements, and then we compute mid again, which will be 2 now. And we compare it to 11. So 11 is greater, and then we compare it to 4, and we come to know that our element lies between the right side. Okay, so we take 2, 3, 4, and then we compute the mid, and then this would be the element we are looking for.
So we are like not taking 2 here then.
Yes,
so
yes, that's true.
Okay.
Yeah.
And we keep repeating. So the mid element over here is 3.
Yeah, and this is what we are trying to find. So
yeah, so we can like directly like return 3.
Yeah.
So let's write a program for it like in the similar way. Do you even want to write it? Like, do you want to take it? You can open the Ethernet pad and you can write it.
Sure. Let me try to get the link 1 second. Can you ping the link in the chat window of the Etherpad? I think I got the link. That's fine. Okay, so we have already wrote this. So we'll run the loop. Let's say while start is less than equal to n.
Let me ask, like anyone have any question up until here? Okay, let's continue.
Okay, so we'll compute mid in the same way. And divide by 2. Then we compare if mid, if array of mid. We can do the same comparison if it's equal to target. Then we return. Oops, I missed the bracket. And otherwise, before going or picking the size, we'll do. Okay. Array of mid is, say, as an array of start so we need to know which.
If array of mid is less than array of start, like what this tells us?
Array of mid is less than, that means we need to go on the right side. That means this left part is not rotated.
Yes.
Okay, so in this case we can do mid equal.
If area of mid is like less than start, then the right half is sorted and left half is rotated.
Yes, you're right. Yeah, correct. Yeah. So in that case,
Yeah,
we also need to compare if our number. So what we are trying to search is also like greater than that. So.
Okay, so let me like just write a comment here for simplicity. So this indicates that right half is sorted. Okay, correct?
Correct.
Okay.
Then we also need to make sure that target we are trying to search is in that right half.
Yep.
Okay, so for that we need to. So we can do and array of end is greater than target. Okay, which means the target we are trying to search is on the. We probably would need one more condition here.
Yes. Why don't like you write that condition inside the else if condition? Maybe.
Okay, I will include. Array is less, that means right half is sorted. If it is less than target, then we know that we need to go to the right side for sure. Okay.
If array of mid is less than target,
then we know that we need to go to the right side because that is where.
okay.
So we can do mid equals. Need to go to the right side, right? So start actually. Start equals. Okay. Else, if let's say if array is mid, array of mid is greater than the target. Okay. Means we need to go to the left side because that left side is rotated.
Okay.
-1.
So this is the else if condition where we check the array of mid is less than array of start, which indicates the right half of target.
Correct.
Okay, and then we are comparing the target with the middle element, and if
Correct.
the middle element is less than target, if mid element is less than target, then start equal to mid. I feel like maybe we are missing a condition here, but like I'm not very sure about it. Let's continue.
Yeah, and then we'll have one more else, which would be when the array of mid is greater than the. We should write the condition actually. Array of mid is greater than greater than start. That means the left side is sorted. and right side is rotated. Actually, can simply skip this and just write the else actually. In that case, we need to again compare this array mid greater than the target. Or we can simply use the same. So these conditions will remain the same. Maybe I think we can take this example and run it. Yes.
I believe there is like one more condition. We take the condition where mid is less than array of start. That indicates the right half is sorted. And then if you are saying like we are saying like this left half is sorted and the right half is rotated. What if the whole array is sorted?
And I think we can add some quality condition somewhere.
You want help? How many you want? What's wrong? Why you come home late? How long you want?
Start.
What's the canvas for one?
Oh, so I work 6.
Start, that is true. Then in that case, if entire array is sorted, then this should work actually. It should go into else condition. Because in that case, this array of mid will not be greater than array of start, right? If it's completely sorted.
So I think what I'm saying is like, I'm looking at like array of mid is less than target. If it's 3 and the mid is 10, so it's less than target. So you're going to go on the left side or the right side?
Could you repeat? Sorry,
yeah. So this is in the first else if condition. Array of mid is less than array of start. So
yeah.
There you're saying array of mid is less than target. Array of mid is say in this case is the example. The first example is 2, right?
Yes, mid is
2. And 2 is greater, so you go mid minus 1. So you don't go to, it's not less than target, it's greater than target. You go to mid minus 1. So you're going here, the left side, you're searching on the left side for 3.
Yeah, so if array is mid, which is 2, is less than the target, which is 3, we are going to the right side.
And in the next condition, in next array example, the 10. So here it's
this example, right?
Yeah, yeah. Next is put that 5, 6, 7, 8, 9, 10, right? So here the mid is 10. Mid is
okay, yeah,
less than target. So here is it's 2. 3 is less than target.
So in this case, we should not come into this else. So in this case, array of mid is 10 and array of start is 5. So 10 is not less than 5, right? So we'll not come into this else. We'll go here.
Okay. To the next else. Okay. And then next else and else if. So there, then mid is less than target. Here again, mid is 10. So it's less than target.
It is not less than, right?
No,
target
is less than target. So mid minus 1. So, okay, target is 3. So mid minus 1.
No. So array of mid is 10 and target is 3. So yeah, we'll get into this condition. mid minus 1, which means we are at 10. Actually, this would be the, okay, I think, yeah, and is equal to mid minus 1, so we'll get into this, mid minus 1, 9. Yeah, I think there is a problem.
Yeah, that's what I'm thinking. Something is, some other condition needs to be there.
Okay. So if I go, so if the key then we are
the condition that like we are missing over here is let's start like from the beginning. Okay, I will remove like this if statement like for simplicity. Okay, if like we will calculate the middle element, and if array of mid is equal to target, then like we will like straightforward like return the mid element, correct, and the one that you wrote. And then there are like three conditions in my view. One is the one that you wrote, where array of mid is less than array of start, which means that, which indicates that like right half is sorted, okay, and left half is rotated. In the similar way, I believe like there should be one more condition. If array of mid is
greater than array of end. Yes.
Yeah, array of end. Okay, this means like the left half is sorted.
Yeah.
Okay, our left half is sorted, or in the else condition, this means like the entire array is sorted. Whatever like the array we are looking into, this is sorted. Okay, so these are like three base conditions that we have to like first verify, and based on that like we can set the start and mid. Okay, so in the last condition, it's very similar to what we did earlier.
Yeah.
Okay, if mid element is less than target,
then we need to go on the left side, so this will become mid minus 1.
No, if
I mean end. Yeah.
Mid element is like less than target, so which is correct. So here is start equal to mid plus 1.
Yeah, correct. Yeah, this is fine.
Okay, and then otherwise like we will move the end to the left of the middle, which is mid minus 1. Okay, and here like I believe like we need to have like one more condition, because we are saying the right half is sorted. Okay, so if the right half is sorted, we just need to check if our target element is greater than the middle element, and also the target element is less than or equal to the end element. Okay, so we are just checking that like it is in the range. Correct. On the right, which we are saying is already sorted. So we start the mid as mid plus 1, otherwise like we set the end to the middle minus 1. And in this scenario, like we will do the same thing. We are saying that left half is sorted, so we can simply check if array of start is less than equal to target, and array of mid is greater than the target. Okay, which means our target element is in the left half, which is already sorted. Then start should be
mid minus 1.
End should be mid minus 1.
Yeah, sorry, yeah.
Okay. Otherwise, the start should be mid plus 1. So I believe like this should cover like all the use cases.
Yeah, because this first if doesn't like check if that range last element is still correct, because it might be rotated from near the end or near the start, I think.
Okay. Any questions on that? And what should be the time complexity of this one?
I think still log n, because we are discarding 1/2, which is not rotated.
That should still be log n because we are still applying the binary search and discarding half the element like at a time. Okay. I believe like I don't have like good examples like today that I can show up. So if someone want to like come up with the examples. Anwar is asking if mid equal to start plus end by 2. Yes, which is correct. Yes, that is correct.
Will the code work if the number is the same number? Like if I just have like 555555555?
Yeah, that's a good question.
But then it will return the first if only. If I mean, it depends what we are trying to find. So
Let's try both, right? Let's try finding a number like 6, or let's finding 5 itself.
If it is 5, then like maybe we can return the any index, because we just need to like match any index which is 5. And if we have to find the 6,
do you know how rotated it is? How do you know whether it's rotated or not?
I think it will directly come into that else condition, because it will not meet any other condition. Last else. And I think we need to add equal as well here in the on line 84. Otherwise this will not return.
I believe like it will directly cover from line 17.
So if okay, for 5 it will cover. Yes, I was thinking from here 6 will anyway not return anything. It's not there. What I was thinking is, for if we are trying to search 6, then we'll go into sorry, mid will become first if condition. No, we'll not go into that. Less than, we'll go into else only, wherein mid is less than target, and then we go to the start mid plus 1. Again we are trying to search in right half. And loop will end without searching for, I mean, will not find the element.
Yeah, so Hugh is saying like it will always go to line number 87 if the target is not 5.
No, it depends if it's greater than or less than. But it will go into this else at line number 83.
Yeah, like it will go inside else, and then it will either go into like, depending upon the number is less than the target, like the middle element is less than the target or greater than the target, and eventually like, it will go out of this loop based on the while condition.
Yeah.
And it will return -1. Correct?
Yeah, I mean, we are not returning -1 though, but yeah, we can do that.
Is that correct, Vivek?
It'll return -1 for everything. I think we are not returning from inside the while loop if we find. Oh, we are returning. Sorry, yeah. Return mid is there on line 71. Yeah, this is fine then. Yeah.
So another question is, if the array itself add negative numbers, would this work? In an array, given array, it's got negative numbers.
So let's take an example.
Yeah, then we can't do the return -1. We should throw an exception or something. If it is, that's
Yes,
only.
like
That's one thing.
we are just taking like return -1, but
Yeah,
we can just say like integer dot like maximum, like minimum value or something.
Yeah, but otherwise also I was thinking, even the whole code, it should work technically because we are comparing less than the value, but
Because anyway, like indexes should be, we are returning the index here, so index should be always like 0 to
yeah.
some number. Yeah. Okay. Any more questions, like Vivek, like the one that you asked on? Is that what you're looking for?
Yeah, but how do you know is this rotated or not? Like, where is it rotated?
I think since we are going in the else condition on line 83, it is not rotated essentially.
So you assume that it's not rotated, right? Even though, I mean, it's all the same number, so
Yes.
whether it's rotated once or 100 times, it shouldn't matter, right?
Yes. Yeah.
Makes sense. No, makes sense.
Okay.
We can get to the next question.
Okay, let's go to the next question then. Let me like open the Leetcode to figure out the question. Let's take an example like that is given. So the question is, giving a string with 3 operators, subtraction, addition and multiplication, just give me a second. Maybe I can copy the question too. Okay, the question is, given a string of numbers and operators, return all possible results from computing all the different possible ways to group number and operators. The valid operators are plus, minus and multiplication sign. So the operators are, we just have like 3 operators here, and these are the number of combinations that we can have. We can insert parentheses at like different places, and all of these are like valid equations, and depending upon like where we are putting the parentheses, our results will vary. Any question on the question? I hope like this is clear to everyone.
So I've noted that it doesn't, in the explanation, we don't have any plus operator. Can we use, so we'll only use what is given in the input, only those operators?
Yes. So a string is like already given to you. Let's take like a different string. We have 1 plus 2 minus 3 multiplication sign 4. Okay. So these are the only 3 operators that we can use.
Right.
Okay. And depending upon like how we want to insert the parentheses. Okay.
Right.
So we can go with this, and then this, and then this. Correct?
Yeah.
So what should be the result in this case?
So 3 minus 3, 0. Will be 0.
0. The other combination, let me first write it. 2 minus 3 multiplication 4. Then we can combine maybe these two. This way. So what should be the answer in this case? Like
It will be 4.
2 minus 3 minus 1.
Yeah, and then there is a
1 minus 1, 0.
oh, it is plus, yeah.
Yeah. So it should be again 0. Okay. So just like given in like the first example, we can combine like it in like multiple ways. So how can like we go about solving this? Okay, use a stack. Anwar, can you like elaborate like a bit more? Okay. This is like a little different from couple of other questions where we have already given a string which contains parentheses, and we are trying to evaluate the equation using a stack. Here we are given like a open-ended string without parentheses, and we have to figure out all the possible combinations, like all the possible ways like we can insert the parentheses and make sure like it is a valid equation. Okay, he was saying recursion with solving one operator at a time. Do you want to like elaborate like a little more on that?
I don't know. It's just idea. It's just basically let's say for your equation at line 122, you solve 1 plus 2, and then you get 3, right? And then you use recursion to solve 3 minus 3 times 4 again, and then the next loop you solve 2 minus 3, and then you got -1, and then you solve 1 plus -1 times 4, and then you use recursion to solve it again, and then you solve 3 times 4, which is 12, and then you solve 1 plus 2 minus 12, and then you recursively call the same function again. And yeah, it's just idea. I don't know how to do it.
Yeah, okay. Let's take that. Let me like write this problem like in a different way, like two more variations of it. So let's say like very similar to line number 116 and 117. If we put the parenthesis at the last one, and then we add it here, and then these, or the other way around. If we add the parenthesis to the middle string, like this middle portion first, and then we solve from 2 to 4, and then we solve like for the whole string. So what should be the answer at line number 119? 3 into 4, 12.
12,
11.
and then
2 minus 12, 10, and then like minus 10.
Minus 10. Minus 9.
Minus 9. And what should be the result here? 2 minus 3 minus 1 minus 4 minus 3. Correct?
Yeah.
And so what we can do, we can take the string, we can like in a for loop we can start iterating on the string. Okay, as soon as we find the operator, okay, at this point of time our solution should be 1 plus all the answers that we can get from get like with the remaining string, which is 2, 3 and 4.
So there's another parenthesis we can put for 1 plus 2, 1 and 3 times 4 also 1, right? Minus.
Yes, like there are like a number of ways, because as with the first solution there are total 5 ways that we can do. Okay, so which case like I'm missing here?
So 1 plus 2 in parenthesis minus in parenthesis 3 times 4.
Yep, so the case that I'm missing, 1 plus 2. Correct?
Yeah.
So what should be the answer here? Like 3 minus 12.
Minus 9 again.
Minus 9.
So duplicate it. Yeah.
Okay. So like first of all, like I want to like focus on this scenario, the one that like is highlighted. Let me like put them here. Okay. So if we have to like take this equation, okay, essentially like what we are saying, if we divide the string at plus operator, then 1 plus all the answers that we can get with is remaining string, which is 2 minus 3 into 4. So we are trying to like solve the string like recursively. So if we can get like only this string, like if we take only the remaining string, which is 2 minus 3 into 4, what can be like all the different combinations here? 2 minus, let me like first copy that string. The first combination can be 3 into 4 and then including 2. The second combination can be 2 into 3, correct? And then we include 4. So these are the 2 combinations that we have. Correct? Any question on that? So what should be the answer like in this first case at line number 133?
Minus 10.
What is the answer like at line number 134?
Minus 3. Just 3.
Is it 3
Oh,
or like
yeah. No, minus 4. Yeah.
minus 4? Okay, so we get like 2 answers. Okay, with this remaining string 2 minus 3 and 4. Okay, now what if like we add like 1 to it? So if we are going to add like 1 to it,
Minus 9.
it should be minus 9. In the similar pattern, like if we add 1 to the next string, it should be minus 3. Okay, and if you see like these 2 answers are exactly same as minus 3 and minus 9.
Yeah.
Correct?
Yes.
So those are the two possible answers by just like dividing the whole string at the plus operator. So whatever the answer we get at what are all the answers that we can get from the remaining string. Okay, we just need to add like 1 to it. So can we like do the same thing like in the recursive way, keep doing it like for the whole string and then combine all the answers? Is that correct? Let's try that. So these are the two possible answers. Now again, if we keep continuing, we get this plus operator. We already like looked into that. Next time like we get this minus operator. Correct? Yes, we need to do it like for all the operators in the string. So if we divide a string around this minus operator, then if I write it this way, let me like write it, all the answers that we can get with one plus two, so this is the first set minus all the answers that we can get with 3 plus 4.
Three times 4, right?
Yeah, sorry, I'm sorry, it was times 4.
8 times 4. So
my bad.
that's okay.
Okay, so we already like looked into, we got like these two answers, so I will like just like make a star here that we already covered these.
Yeah.
Now the remaining set is okay. This is like our whole set like on the top. So we went with this one and this one. We already covered like these two solutions. Okay, now what are the different number of ways we can solve this string 1 plus 2? One way, correct? Any question on that? Because if your string is like on the left, we are saying all the answers that we can get with the string 1 plus 2. Okay, so 1 plus 2 is the only string. There is only one way like we can put the parentheses around this to make it a valid equation, which is this one. So we will get the 3. In the similar way, like how many ways like we can get the answer for 3 multiplied by 4? 3 into 4, correct?
Yeah.
It is 12.
Yeah.
Okay, now if we combine the answers, what we are saying, the number of ways we can get the answers is 1 plus 2, which is only 1, 3, and the number of ways we can get the answers with 3 into 4, which is 12. Okay, if we subtract 3 minus 12, minus 9, okay, which is similar to the last equation on line number 120, correct?
Yeah.
Okay, so we covered this case. Now let's move our string to star. So as we are iterating the string, like we will reach to the star operator. So here we are saying, let me write it, all the ways that we can get 1 plus 2 minus 3 multiply by 4. Okay, we should wind up
only
like,
one way. It's
yeah.
only one way, right?
Yeah. So it should be like very similar, because we are like over time. I'm sorry about that. 1 plus 2 plus 3, and so there are like two ways. Either like we can do this, okay, or we can do 2 plus 3. So in first case the answer is 0.
Yeah.
In the second case answer is 2 minus 3 minus 1, which is 0. Okay, and then we multiply 4 to it.
Yeah.
We get 0. Okay, so which covers like the first two cases. Okay, so we can like definitely use the recursion, break the string where we get the operator, and then combine like all the answers. Like we get like multiple answers based on, as we do recursive, we can get like multiple answers. We can combine those all answers, and then in a for loop, like we can multiply it with the left onto the right. Like when I say multiply, like just not multiply. If it is a multiplication operator, you can multiply it. If it is a like plus operator, you can like add it, as you saw in the first case. If it is a negative operator, then like you can subtract like the answers like in both the sets, and the combination of that like will give you the complete set, the way you can get like the answers with a given string.
Yeah, I don't understand how this is a medium Leetcode question.
Okay.
This was the medium, right?
This is a medium, yes.
I have no idea why this is medium. I mean, it sounds super complicated.
Yeah.
All right, I think what we'll do is, I think we are a little over time here. Let me stop the recording, and then we can continue chat for another like 10 minutes if people want to. All right.